Calculating the distance between 2 points is one of the most important things we'll need to be able to do, since a lot of the problems we're going to talk about come down to thinking about the relationships between distances. So first, think about the case where we have 2 points like A and B that are horizontal to each other. That is, the line through them is a horizontal line. If we extend the segment through AB to the point P on the y-axis, and think back to classical geometry, the segment addition postulate says that PA plus AB is equal to PB, where AB is the value that we're trying to find. It's just between our 2 points. Now, our definition of the coordinates of a point says that the directed distance from A to the y-axis is its x-coordinate. So AP is x1. And similarly, PB is x2. So if we solve this equation for AB, we get AB is equal to x2 minus x1. Now, when you're doing this calculation, it's important to keep the coordinates straight. x2 is the coordinate of the right-hand endpoint, where x1 is the coordinate of the left-hand endpoint. Keeping this order guarantees that the distance is always going to be a positive number. Since we're talking about the physical distance here, not the directed distance. Another way you'll also sometimes see this written, just to guarantee that we get a positive result and you don't have to worry about which number comes first, is you'll see this written AB equals the absolute value of x2 minus x1. Now it's always going to be positive. You don't have to worry about who comes first and who comes second. Now, before we go any further, some of you might be questioning the case where the points are on opposite sides of the x-axis, right? In that situation, CD is actually the longest of the 3 segments. So our segment addition equation would be CD equals CQ plus DQ. Now, in this case, QD or DQ is still x2, but CQ, because remember, we want the absolute distance, not the directed distance. So CQ would be negative x1. And this is the same as x2 minus x1, which is the same formula. And again, if you like, you can also think of this in absolute value. That way you guarantee a positive result. Now, if you repeat this same argument, but with the 2 points arranged vertically instead of horizontally, you'll get a similar formula for the length of a vertical segment, but with the y-coordinates instead of the x's. So how about the case where the 2 points are diagonal from each other, rather than being straight up and down like the points we've talked about so far? So to find that formula, I'm going to start off with 2 points. Nothing special about them, just 2 arbitrarily chosen points in the plane. And I'm going to give their coordinates some labels. I'm going to call this one x1 comma y1, and I'm going to call this one x2 comma y2. So then what I'm looking for is the length of this segment, right, the segment connecting them. And I'm going to call that D. Now to find the value of D, what I'm going to do is I'm going to build a right triangle off of these points, right? So I'm going to have one side down here on the bottom. I'm going to have another side up here, right? And the coordinates of that point down there at the bottom, right, at the right angle of the triangle, are x2 comma y1. Now, using these points, I can come up with the lengths of the 2 sides, of the 2 legs, right? The length of the bottom leg is going to be x2 minus x1, and the length of the upper leg is y2 minus y1, and that's what I need to know to come up with my formula. And all I'm going to do here is I'm going to use the Pythagorean theorem, right? D is the hypotenuse, so the theorem says d squared equals, I'm going to do the bottom leg first, x2 minus x1 squared plus y2 minus y1 squared. That's the other leg. And really, that's almost it. I just got one more thing to do because I want a formula for d, not d squared, right? So to get d by itself, I'm just going to take the square root of both sides, and I'll get d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And there's my distance formula. So I've written out our results here, right? A nice formal statement of what we've done. Right? So the formula here says, given 2 points on a plane, x1, y1, and x2, y2, that was my starting point on the last slide. And the distance between them is given by this formula here. All right, so there's a formula, right? So in the next slide, we're going to look at some examples, just to kind of get a feel for how this formula can be used to answer some specific questions.